Hi, I'm Andy Wong from Tsinghua International School. Heart diseases has always been the number one killer of all diseases in the world. Approximately every 40 seconds, someone in the United States experiences myocardial infarction, also known as a heart attack. In 2019, in the United States, heart diseases has accounted for a death number as much as the population of San Francisco, specifically 874,613. Untreated heart disease may be life-threatening. However, the expense of having a cardiac diagnosis is tremendously high, both timely and financially. Usually it takes thousands of dollars for one cardiac diagnosis. The consequence of going to the hospital led to many people choose the other option, ignore it. To solve this problem, we have created an AI project specialized for giving cardiac diagnosis directly based on MR images of the patient's heart. Though MR images of the heart still has to be taken, all the network needs is 2 MR images of the patient's heart. Our project can be divided into 2 tasks: semantic segmentation and verbal diagnosis. In the semantic segmentation task, the cardiac regions on the MR image of the patient's heart are divided and labeled by UNet, a deep learning network non-stack collecting details of the image in both global and local scale. The labeled parts of the heart can then be used to calculate heart metrics of the patient, allowing us to perform further calculations on identifying the patient's disease. The semantic segmentized image is then passed to the point-bird model to perform the verbal diagnosis task to generate a verbal diagnosis that will be given to the patient. To further improve the accuracy of our UNet model, we have integrated the intention mechanism into our UNet model to enhance its ability to focus on important features. We have also used the Geometric Visual Similarity Learning Network, shortly GVSL, to pre-train our UNet model to learn the topology of human cardiac structure. In our test of 4 variations of the model with or without GVSL and attention mechanism, each trained 500 epochs, the initial UNet model had a loss value of 3%, while the GVSL pre-trained UNet model integrated with the attention mechanism achieved a significant lower loss value of 0.7%. To enhance our point-bird model, we have utilized the well-developed visual linguistic models by pre-training our point-bird model with the ULIP network, also known as Unified Representation of Language, Images, and Point Clouds for 3D Understanding Network. We have tested on several different evaluation models to score our generated verbal diagnosis. As a result, using consensus-based image description evaluation, SIDE-R for short, has achieved the highest scoring, being 0.724, while using the bilingual evaluation understudy, BLUE for short, achieved a poor scoring of 0.261. Talking back to the design of the project, obviously, several issues lie within the project. Though our project manages to greatly reduce the expense and difficulty of a cardiac diagnosis, a set of MR images of the patient's heart is still required, which usually is expensive to take. Also, the verbal diagnosis seemed to be a bit meaningless, due to the reason that the network does not provide the patient with a treatment, and it seems better to return the type of cardiac disease to the patient directly instead of a wordy description. Getting to this point of the video, 6 people have suffered a heart attack in the United States since you have started. It is important to identify the diseases that lie within your heart as early as possible, before it is too late. And this is why we have created this AI project, to make it easier for you to have a heart diagnosis.